Okay, question 36. Find the following if the first term of a geometric sequence is 8 and, okay, the sum of the first three terms is 78. Find the common ratio. Okay, well, we know that the first term is 8. Okay, we know the sum of the first three terms. Okay, and actually, sorry, I should do it like this. If I'm going to say the sum of the first three terms, I should utilize the subscript there. We'll say that the sum of the first three terms is equal to 78, which also gives us n is equal to 3. So if I use that equation that requires me to know how many terms there are, that will be the sum is 78 is equal to a times r cubed minus 1 over r minus 1. Okay, but I don't know what that is, but I'm going to solve for r. R is the only unknown that we've got here. So what are we going to get here? Actually, in a case like this, I would be very tempted to go to the calculator because of the cubic in here. When I multiply through, like we haven't talked a lot about cubics. So what we're going to do here is probably go to the calculator and graph this. Okay. So we've got two sides here. What we'll probably do here is we'll put this into the calculator, 8, and then make that x to the power of 3 minus 1. Whoops. Got to make sure you come out of the exponent when you do that. Minus 1, and go out here, divided by another bracket, x minus 1. Press enter. Does our little graph there, and then we're going to graph the second one here will be y equals 78. Now I know you're not seeing this here. That's okay. I'll show you in just a second here, because what's going to end up happening is my window's not going to be good for this at all. So I got to change that, and I got to change my window settings, make my my y max at least greater than 78, so that you can actually see what's going on here. So I'm going to go right up to 100. Okay, and so here's the expression that I get. Okay, so the notice again that expression, that equation that we just got here, is roughly giving us a parabola here, and that's because if you take an x cubed and divide it by an x minus 1, that's going to work out to be a quadratic ultimately. Now, there is a way that we could have simplified that algebraically, but again, you haven't seen it at this point here, so we really can't go through and do that. But now what I'm going to do is I'm going to look for the intersection here. Analyze graph, go down to intersection. Okay, now this is very similar to what you do with the TI 84, except I open this up and it just gives it to me right away here, and I'm seeing right there that the x value of that point of intersection is going to be 2.5. Okay, so one value here would be r is equal to 2.5. However, it is giving me a second opportunity, or a second option for this. So let's try this again. Window, analyze graph, intersection. We're going to come over here, and it's giving me another one here, and I can see really quickly. Whoops, sorry, it didn't take there when I hit it. Negative 3.5 as well. So we've got two different r values that could give you the same sum. And we've seen that before, where you could get, like for example, the plus or the minus giving you the same sum.